Okay, so example 5 is our first example where we are going to be drawing horizontal slices because they want us to rotate it about the y-axis. So we have a vertical axis of rotation. So when we draw our perpendicular or perpenwascular slices, they're going to be horizontal. So in this case, our outer radius is going to be this function here opening up, which I believe is going to be the y equals x squared, but we're going to have to get that in terms of y, so if we were to solve it for y, we would get square root y. Nope, that's a little small, hard to read. Okay, which means the other one we should go ahead and get in terms of y, and so that would simply give us y squared equals x. Okay, so we've got everything in terms of y. So for that outer radius, we're going to have right, which is square root y, minus left, which is here at x equals 0. And then our innermost radius, oh, he's real tiny here. It's not the best illustration. R, forgot to label him big R. But he's going to be that y squared function as the right minus 0 as the left. So everything else for the most part is the same, except things are in terms of y. That's a slice, not cis. So we're going to have pi, one radius minus the other one squared. And this time our little height of our discs is going to be dy. So that outer radius is simply square root y, no need to keep the minus 0, and this one is y squared. So then to find the volume of the solid, make sure we're thinking with respect to y when setting our bounds on the integral. Okay, it's going to go from a y value of 0 all the way up to a y value of 1 of square root y squared minus y squared squared dy. And obviously, like I've said before, when you type it in your calculator, if you want to simplify these expressions, feel free. But on paper, I like to do them consistently. And this one should estimate to be about 0.942.